Everyone, in this video we'll work through a little bit of your Chapter 1 review packet. Now if you need any help on anything in the chapter review packet, do know that you can always use the other packet that will be provided to you in class to help you out on how to solve certain problems. For example, let's say that we were to go to, I don't know, just some random page here. Oh, look at this. This is asking us to sketch the graph of equations and then also solve the equations. You can see here you're getting a system of equations. So maybe you forgot how to solve systems of equations. You can reference the packet that you also have in front of you. It looks like this here. And in here, this is basically just a set of examples explaining how to do various types of things. So for example, you might need to look for slope, distance, and midpoint of 2 points, or you need to solve a system of equations. Oh, there it is. We need to solve a system of equations. So here you can just use this as reference and understand how to solve a system of equations. And then you can go back to your notes and then do it then. Okay. But for this video, let's go ahead and do number 1 together. Okay. All right, so it says plot the points -4, 7. I'm going to go ahead and do that. And -4, 7 will be up here. That'll be point A. Okay. And then B will be -2, -1. -2, -1, right there. Okay, and then what we need to do is find the length of AB. So what we're looking for is this line, its length. And so if we're trying to find its length, we're trying to find the distance from A to B, which means to find the length, we'll need to use the distance formula. So AB's length is going to equal the square root of, now given those 2 points, what we need to do is basically you can see that you kind of create the Pythagorean theorem or a right triangle there. So to find that distance, which is technically like the hypotenuse, you're trying to find the length of the x's. So to find the length of the x's, let's call that x1 and let's call that x2. You simply subtract them from each other. So -4 minus -2. And then we're going to square it as part of the Pythagorean theorem. And then we're going to find the distance between the y's. The distance between the y's is 7 is y1 and -1 is y2. So plus 7 minus -1 squared. And we're going to square root all that. That'll give us the hypotenuse of our right triangle, basically. Okay, so let's go ahead and solve that. So we have -4 plus 2. -4 plus 2 will give us -2. And then we're going to square that. Plus 7 plus 1 is 8. And then we're going to square that. And don't forget that everything is still within a square root. And then we're going to get -2 squared. That is 4. And 8 squared is 64. So we have the square root of 68, just like that. Okay. All right, now let's see here. One thing we can do is there's a process of just making sure that the radical is simplified as much as possible. So I'm just going to break that up as much as possible as well, actually. 68 is made up of 2 and 34, and 34 is made up of 2 and 17. So since square roots have groups of 2, I can leave this as 2 square root of 17. And that'll be my answer. That's the length of AB. The next question asks us for the midpoint of AB. So the midpoint of AB is going to be somewhere in the middle here, right? I don't exactly know where that is. Graphically, it's kind of hard to pinpoint since it's not a very accurate graph. But since it's the midpoint, I can kind of think of midpoint almost like average. And so to find the midpoint, I'm going to take the average of the x's, which is -4 and -2, divided by 2. That gives me the average. And then I'm going to find the average of the y's as well. So 7 plus -1 and divide that by 2. So that means that my midpoint will be at -4 plus -2. That's -6. -6 divided by 2 is -3. And then 7 plus -1 is 6, and 6 divided by 2 is 3. So my midpoint is at negative 3, 3, which, yeah, it's pretty spot on right there, isn't it? It's around negative 3, 3. Okay, so that's going to be my midpoint. All right, so that's part 1A done. Write the equation of the line of AB. All right, so we already have our 2 points. I guess all we got to do then is if we need an equation, we definitely need a slope, and we need one of those points. We already have those points. It's given to us, right? It's already here. But what we need is a slope. So let's go ahead and find the slope of AB. The slope is given by y2 minus y1 over x2 minus x1. So that's going to be, if I were to write this out again, x1, y1, and x2, y2, then what I have is negative 1 minus 7 over negative 2 minus negative 4. That'll give us negative 8 over negative 2 plus 4 is going to give us 2, and so our slope is negative 4. So now that I'm 4, I can write my answer in one of two ways because I have 2 points. I can use point A, and if I use point A, I can write it in point slope form. Point slope form is y minus y1 equals m times x minus x1. Therefore, I would write y minus the y1 of A is 7 is equal to the slope of negative 4 times x minus, and x1 is negative 4, so x plus 4, just like that. And that can be my final answer. I can leave it in that form. That's perfectly acceptable. I could just as well have wrote it using point B. If I use point B, I would write y minus negative 1, or that's the same thing as y plus 1, equals the same slope of negative 4 times x minus negative 2, or that's the same thing as x plus 2. And this would be an acceptable answer as well. Both of them are the same equation to AB. And then the last question here says, which of the following points are on the line AB? Well, the only way to test that out is to plug the points in. Okay? And so if you plug the point in and you find out that it works, then it is a point that is on AB. If you plug a point in and it doesn't work, then now you know it's not on the point AB. Okay? Let's go ahead and try one, for example. So again, it doesn't really matter which equation we have because they're the same equation. I'm just going to use this one just for the sake of it. So we have y plus 1 equals negative 4 times x plus 2. Okay. So if we plug in the x value, negative 1/2, right here, just like that. And then we can also plug in the negative 9/2 right here. Let's see what we end up getting. Negative 1/2 plus 2 is going to give us 3/2. And 3/2 times negative 4 is going to give us negative 6. On the other side, we have negative 9/2 plus 2/2, which is negative 7/2. These are not equal, so therefore this is not on the line AB. Okay. Let's try the next one. So if we can try the same equation, y plus 1 equals negative 4 times x plus 2. Again, we'll say that 5/2 is the x value. So if we add 2 to that, we'll get 9/2, and then multiply that by a negative 4. And therefore we'll get, what will that give us? Negative 2, negative 18. On the other side, we're going to plug in negative 19 plus 1, and that, oh, look at that, that gives us negative 18 as well. So yes, this does work. Therefore, 5/2 and negative 19 is on AB. Just like that. Okay, all right, so that concludes number 1. You're going to finish up the rest of the packet on your in class now. You can work with a group member if you wish. Please go all the way through up to number, I believe I said up to number 7. Okay, so finish up to number 7 for class today. Have a good day.